Okay. So you tell me if you didn't get the answer. Normally, like in this unit, if you didn't get the answer, usually I have to come over and take a look at it because there's many ways to solve this. If you make one little silly mistake, and it's harder for you to like follow it through. So if you can walk through and tell me if you have any questions, I'll come take a look. We'll figure it out.
Could you do elimination?
Could you do elimination? Absolutely.
Well, I'm just saying.
If you want to multiply that by 2 or multiply it by -1, you can do whatever you like.
Will there ever
be a problem where you only use one?
Well, there might be a problem like in an elimination where if you did a substitution, you're going to get a crazy looking fraction. You can still do it, but I don't think I'd want to. So what did you do, Jordan? How did you eliminate?
I put a negative in the bottom.
You put a negative on the bottom. So we kept the 2x plus y equals 6, and this became a positive x minus y equals 0, right? 3x equals 6, and x is equal to 2. Find it? Okay, and then just go back and plug it in. Actually, y is equal to x here, so then y is equal to 2. Find it? Sometimes these are so hard to find your mistake because, like I said yesterday, when you walk through it yourself, and I do it with my own, I say, oh, I multiply by a negative. In my mind, I multiply everybody by a negative.
Please
But if I
excuse
miss
the
one,
interruption. I have one final announcement. Ms. Goodman's classes are to report to the library today, and the library will be closed. Thank you.
okay, so any other questions with this one?
Why is she logging this?
She's probably not here and they probably don't have a sub.
Oh, you're right.
Oh.
Which is why they probably closed the library.
That makes
sense.
sense.
I think
She wasn't here
that's
yesterday.
Yeah.
That's what it is.
And for some odd reason, they're short on subs.
Yeah, there's so many teachers out.
Okay, so on this one, and again, pay attention to, this is a parabola and a line. A parabola and a line, you can get 2 solutions, 1 solution, or none. So when you come up with 2, that's perfectly normal. If you have 2 lines, you can only get 1 or none. So kind of focus on what kind of functions you have. If you want to set them both equal to y, set y equal to each other, absolutely you can do that. There's a number of ways to do these. Substitution works out nice, elimination works out fine, whatever way you like to. Okay. There's going to be some today that we do a certain way, but we back substitute. We do a back substitution. But when we get to the elimination, that's why it's always so hard to go through these and to match up, because if you don't do the same thing that I'm doing on the board, we have to follow your mistake through. Okay, in this one I did a substitution. I don't want to substitute for the x because then I'm going to have to cube it. So I want to substitute for the y. And yesterday you guys were coming out with, you got these 0, you got their plus or minus radical 3. Just remember to take this equation and bring this back down to this one and these, and find your corresponding y values. And radicals, just leave them as radicals. The next one too, this one you had a parabola and a line again, and we only had 1, so we only had to touch once, so that means your line is tangent to your parabola. Okay. And whichever way you decided to do this, you can eliminate it. You could substitute. I wouldn't substitute in for x, because first of all you'd end up with a fraction, and then you'd have to square it. I mean, it's totally doable, but don't make them more complicated than they need to be. Questions? We're good? Okay. Here we had a circle and a line. A circle and a line. Don't forget, you can cross it twice. Once be tangent to it, or none. So you can get 2, 1, or 0. And again, we have a cubing function and a squaring function. So it's got a different combination in here. If you find an x, don't forget to go back and find your y. If you find your y first, just remember to find your x, and in the pair, the x always comes first. If you have any questions, just call me over, because these are a little harder when you're trying to see what you did wrong. Good. Okay. Was that it? One more? This guy? Solve for either one, x or y, and just multiply through by that denominator to get rid of that fraction. Remember, on a fraction key change flip or put it in your calculator. Make a little bit more sense as well. We try to find what we're given, and we call this back substitution. So this is our key starting point, and we substitute back into here. We solve for y, then we substitute the y and the z into the first one, and we solve for x. So we call this back substitution. And you'll usually see like the reduced look to it. It'll kind of like come down like a little step ladder. And your leading coefficient up here will be 1. So we'll take this guy. First thing we'll do is plug it into this one. When z is 2, you'll find y. So keep track of your answers. Okay. Then substitute it into this one. Just keep going back. Notice in all these cases, the variables are always in alphabetical order. That's the easiest way to keep these. And when we put our answer, we're going to put them in variables in the same order alphabetically. If you put it in your calculator, you're going to put it in the same way alphabetically. So now we know y, and we know z, and we can find x.
What's it doing?
Because I was about to tell John to take the things off my desk while I was writing, and I said, "Oh, let me write first." Okay, so now, here's your answers. What you can do to give me the solution is to hook them up like this, in XYZ format. And you don't have to write the XYZ. You just leave it in this format. It just has to follow X, Y, and Z. Does it make sense? Okay, this is a nice one. Back substitution. Okay. Another one is with 3 variables, you need 3 equations. Now, your goal is to combine 2 equations, eliminate 1 variable, combine 2 others, eliminate the same variable, and then use those 2 results to eliminate a second variable, and then work yourself backwards. So if you looked at this set of 3 equations, this guy does not contain a z. So if we took these 2 and we combine them somehow to eliminate z, then we can combine that result with this one and eliminate either x or y. Right? You keep eliminating. This is a process of elimination. So we're going to take these 2, and we have to, in this case, we have to eliminate z. So how do you suggest to eliminate z?
Multiply the top one by negative 5. And the bottom one by 3.
Okay? You need to make this coefficient be the same multiple. You put the first common multiple that they find. So between them, 15 is your common multiple. So you'd multiply 1 by 5 and 1 by 3, and one of them has to be negative so that they can eliminate. So all the way across, I usually hook parentheses around everything so that I remember even across my equal sign. I come all the way across with it. Okay, we're going to add these guys. And before you do them, just double check, especially with a negative, that you hit everything right. This was a negative, this becomes a positive, this goes negative, this goes negative. I find the biggest mistakes are in the negatives. Because we're doing all the multiplication in your head. If you make one little mistake, that carries all the way through. So when you add these together, this eliminates. Now, generally when I do this, because there's so many things going on, I usually label, and you can do this whichever way you like, I usually label my equations 1, 2, and 3. Most of the time I do it so that this way I could say we're combining 1 and 3, first and third, second. When you get one of these, if it helps, call it by a letter, because usually what you're going to have to do is combine two others to eliminate the same variable, call that a B, and then we'll combine those two. So now that we have equation 2 and equation A, neither one of them have a Z, we can combine those. So we're going to take negative x plus 3y these are not hard, they're just time consuming. And what happens in these is if you take your mind off of it for 1 minute, it's confusing because it's very hard to find your mistake when you go back. So now if we notice what happens if we just combine these, which one do we eliminate? We eliminate x, so this works out very nicely. And your answers can also be in fractions. We divide by negative 2. So again, we've got an x, a y, and a z. So right now we just found y. So you're going to back substitute. You're going to substitute it back into either equation 2 or equation A. Which one do you think we should substitute it into? 2. That one is already given to us. A we kind of manipulated. So we're going to plug it back into 2. Negative 3. Why do I keep doing this today? Right?
Wasn't it negative 4?
It is a negative 4. Thank you. You got to catch me all the way through because if we make one mistake, we follow it all the way through. So this will be 1 and then negative 1. I'll move that one. So x is negative 1.
Well,
No, x is positive 1.
Yeah.
Okay, x is this is negative, this is positive. Good. Okay, so now, take this guy, you can substitute it into either one of those. Go for the one that doesn't have too many large numbers, make your life a little easier, so let's go for number 1. The nice part about this is now, the one that we did not manipulate is this guy, the third one. So once you get your answers, plug it into equation 3 and make sure it works. If we use this one, and now we're using this one, the one we didn't use was equation 3. That's the one you want to check everything in. So now you're going to plug in your x. And get the last one. Okay, and again, your solution, write your solution in XYZ. Okay, make sense? Okay, that one's not so bad. Good. Okay, last one. Last one's a little trickier. Again, we have three equations. And this is where it's a little tougher to check your work as well, because it's up to you which two you combine to eliminate one. You may not do the same as me, you may not do the same as your friend sitting next to you. It doesn't mean yours is wrong. You just will come out with the answers in the end. So if you eyeball these three, we're going to combine two of them to eliminate one variable. Then we're going to combine another two to eliminate the same variable. So I usually try to do it this way. If I'm going to combine this one and this one, these have opposite signs, then I can combine this one and this one, it has an opposite sign. If you want to say this has a 1x, I can combine these two with the negative, I can combine these two with the -2. Whichever way you want to combine it is fine. You just have to follow it through. So what variable do you want to eliminate? Which two do you want to combine? 1 and 3. So what are we going to eliminate? Just Z. You can only eliminate one at a time. So you want to eliminate Z?
Yeah.
So what do we have to multiply the top by? 3. So I'm just going to bring this underneath. Okay, so we're going to add these together. This should come out. We're going to call this A. Now, you're going to pick two others, and you're going to eliminate Z. So which two would you like to eliminate? We did 1 and 3. You can absolutely do 2 and 3. You're going to have to use the same one for one of them, right?
Yeah.
So let's do 2 and 3. There's no wrong way. There's no wrong way to eliminate. It's what you look at. I have kids that, it's funny. We're creatures of habit. Some kids always eliminate X first. No matter what the equations are, they always eliminate X. So it depends what you want to eliminate. So now 2 and 3. What are we going to have to do?
Multiply 2 by 3, and multiply 3 by -2.
Okay, so just for a sidebar, it might have been easier to combine these two, 1 and 2, because you could have multiplied this by 2, right?
Yeah.
But that's fine. We can absolutely do this.
Okay.
So let's multiply this by a 3 and multiply this guy by a -2. Just so that you see there's no wrong way to do this.
So you need to get rid of the Z a few times.
We're going to you have to combine 2, get rid of one variable, then combine 2 others, get rid of the same variable. So that you're left with 2 equations with 2 of the same variables. So, and like we were just saying, if you combined 1 and 2, it would be a little bit easier, but this is certainly doable. 6x minus 3y minus 6z equals 6. Make sure you go all the way across. Okay, so now our z's are going to eliminate. This we're going to call b. Now, a and b at this point should have the same variables in it.
But, okay.
Ah, okay.
4x minus 7y equals 8, and 4x minus 7y equals 2.
Ah, is this possible?
No.
So So therefore, what's the problem with this guy?
No
No
solution.
solution.
It's a joke.
No, it's not a joke. Sometimes you have a systems of equations that don't have a solution. So I need to show you that it's possible. Otherwise, what happens when you do this and you end up with that? You go do this about 5 different times. Because you say, oh, something's not right here, something's not right. It could work out that these don't work out. Again, if you wanted to eliminate, say you multiplied this, say you didn't spot this. Say you multiplied this by a -1, or let me multiply the top by a -1 just so I could bring it down. When you added them together, you would see everything reduce, and we say, nope, this is not equal. But you didn't have to spot it right away. But just so that you know, there's times where you have no solution. Now, ultimately, if this worked, if this was doable, we would combine these, and we would eliminate one of those variables. Then, like we just did in the last one, back substitute into them. Just back substitute until you get all the way to the top. The last one, you're going to substitute into one of these. And then use one that you didn't change to test them. Just throw them all in there to test. And it happens that you work the whole thing out and you don't get a solution.